Hello guys. This is your little video summary on last week's lesson on the ultimate guide for using DESMOS on the SAT. So I'll just be going over all of the questions that we did in class, and then you can look and review this video if you want to kind of look back on the questions that we did and be reminded of it. So this is what I'm giving you. So to start off, we first talked about solving equations and systems of equations. So here I have 4 examples for you. What I'm going to do is I'm going to split my screen. Actually, before that, just want to show you DESMOS. I'm going to remind you guys to put DESMOS into the test prep setting. So what you're going to do is you're going to go to the Math Tools drop-down menu and then select Test Practice. And then from there, you're going to choose your assessment. And you just type in SAT and choose College Board, SAT, Suite, and AP exams, and then choose the graphing calculator version. So now that you're in the right DESMOS interface, we can do practice questions. So let's look at the first one. So I'm gonna zoom in on this question right here. You have 6x plus 3y equals 33 and 6y minus y equals 5. And the question is asking you, what is the solution to the systems of equations above? And when you look at this question, when they're asking systems, it's always going to be, this question is asking you for the intersection of these two lines. So if you're going to solve this in DESMOS, what you can do if you want a really quick way to solve this question is just to type each equation into each line. So for my first line on the DESMOS calculator, I'm just going to type in 6x plus 3y equals 33. And the second one, I'm going to do 6x minus y equals 5. Now, if you see here, I have 2 lines and there's an intersection right there. So if I click the intersection and then hover over the point, then I'll get my xy point coordinate of 2 and 7. And we can see in the answers, that's answer B. So by using DESMOS like this, by graphing it, you can solve this question really quickly. So now moving on to the second question. And if at any point in this video I'm moving a little too quickly for you, you can always slow it down or pause so you can do the question yourself with me. But for the purpose of this video, I'm just going to go through them pretty quickly, okay? So the next question says, what is the positive solution to the given equation? So here they give you an equation, and again, the fastest way to do this when you're solving for a solution is just to plug it in right into DESMOS. So I'm just going to plug in 55 over x plus 6 equals x. And again, like I mentioned in the last question, solution always means that there's some type of intersection. And in this question, the intersection is with the x-axis. So if you can see here, I typed line 1, I put in the equation, and now on the graph, there are 2 lines, and they both intersect with the x-axis. Now the question is asking us to choose the positive solution. So I'm going to choose the line that intersects the x-axis, the positive x-axis. Okay? And if you zoom in a little bit, you can see that the positive one is intersecting the x-axis at 5. And the other one is intersecting at -11. So the correct answer for this question would be 5. Okay, now moving on to the third question. They give you this equation, 2x squared minus 4x equals t. It says in the equation above, t is a constant. If the equation has no real solutions, which of the following could be the value of t? Now, like we discussed before, no solutions mean intersection, right? And in the last question, that meant intersection with the x-axis. So the same concept applies to this question. No real solutions is like no intersection at all anywhere on our Cartesian plane. So if it says no real solutions, it's not going to appear at all on our Cartesian plane. So when I type an equation in, it's not going to show up. And that's what no real solutions means. Okay? Sometimes it means that it will not cross the x-axis. Sometimes it means that it just doesn't appear. So how I'm going to approach this question is I'm just going to plug each of the answer choices into the variable t. So I can make this a little clearer for you guys. If I put 2x squared minus 4x equals t, instead of using t, I'm going to plug in each answer choice, okay? So for like answer choice A, I'm going to substitute t for minus 3. I'm going to take a look. Now, I don't see any graph or function appearing on my Cartesian plane at all. So this is my first sign that this is going to be the answer because it has no real solutions. I can't even see it on the plane. So A would be my correct answer. But just to show you guys what real solutions would look like, -1, if I plug -1 in, it shows up as two intersections on the x-axis, okay? And same with answer C, and same with answer D. So you see answers B, C, and D all had intersections with the x-axis, and A was the only one that did not. So therefore, A is going to be my answer. And that's how you would use DESMOS for that question. Okay, now for the last question, it says, how many solutions does this equation have? So again, I'm going to plug it into DESMOS, but now I'm going to do it a little bit differently. Because if you look at this equation carefully, it can actually be separated into two separate linear functions. The first part, 10 times 15x minus 9, that is a linear function. And then on the right side of the equation, we have minus 15 times 6 minus 10x. That's also a linear function. So if I separate this equation into the left and right side, I'm going to see that I have two lines. And what I'm going to do is I'm going to graph both of those lines and see how many times they intersect, because that's basically what the question is asking, right? They're asking how many solutions are there. And if the lines intersect once, there's one solution. And if they don't intersect at all, they have no solutions. But if they overlap, then they have infinite solutions. Okay, so those are my three different options that I have for answering this question. So I'm going to go ahead and just put in the left side of the equation on one line. And you can do this by, you can put in a y equals in front if you want to make it like a function or a line, or you can put f at x, but it'll give you the same line, okay? So I have 10 times 15x minus 9, that's my left side. And then for my right side, I'm going to put in -15 times 6 minus 10x. Now I'm just going to full screen so you can see this a little better. But if you see the red line, which is the right side of the equation, completely overlaps with the black line, which is the left side of the equation, right? So, like we discussed before, if the two lines overlap, that means there's infinite solutions. So that's our answer for this question. Okay? So that was a little summary of the first part of this lesson, the solving equations and systems of equations. Now we're going to move on to section number 2, where we talk about characteristics of a function, and specifically, mostly the quadratic function. So what that is it's basically any function that has the highest power being 2. So if you have like an x squared being the highest power. So I'm going to look at these questions and solve them for you guys. So this question gives you a function, and if you look closely, x squared is the highest power, or 2 is the highest power. So it says the function g is defined by g at x equals f at x plus 5. So for what value of x does g at x reach its minimum? And how you're going to solve this is, again, you're going to plug it into DESMOS. So what you can do is you're going to plug f at x in first. F at x equals 4x squared plus 64x plus 262. And you can see if I full screen or zoom out, this gives you a beautiful parabola. And this is your quadratic function. And then go back to the question. It says the function g, so this is a different function, is defined by g at x equals f at x plus 5. So we know that g at x is a transformation of f at x. And then what they're asking is the minimum value or the vertex of g at x. So if you don't want to go through the pain of figuring out g at x algebraically by plugging in x plus 5 into each x value and then expanding and everything, what you can do is use DESMOS and simply go f and then x plus 5. Oh, not that. X plus 5. So by simply putting fx plus 5, they give me a new parabola. If you look on the graph over here, they automatically complete that transformation for you. But you have to remember to put in the f at x function first so they know what function to go off of, okay? That makes sense. And if we go back to the question again, just to reference, they're asking for what value of x that g at x reaches its minimum. So remember, g at x is our transformed function. So that's the green parabola. And if I click on the green parabola and then hover over the minimum point or the vertex, I'm going to see that it is at the x value of minus 13 that g at x reaches its minimum. So then my answer for this question is going to be A. Okay, now for our next question, it gives you another quadratic function, and it says the quadratic function h is defined as shown. In the xy plane, the graph of h at x intersects the x-axis at the points 0, 0, and t0, where t is a constant. What is the value of t? Okay, so here they're not asking for a vertex point. They're asking for an x-intercept. And you can tell that because the y value is 0. So if you don't want to solve for the x-intercepts by setting y to 0 and solving for x and everything like that, you can simply just plug it into DESMOS. So I'm just going to go h at x equals 2x minus 4 squared minus 32. And you can see over here, they give you a nice quadratic function once again. And what we're looking for is the x-intercept. So I'm going to zoom in on these, and I can actually see exactly where those intercepts are if I click on the parabola and then hover over the points. So let's look at the second sentence of the question again. It says that this graph intersects the x-axis at the point 0, 0. Oh, I can see that. Yep, 0, 0, and t 0. So I'm just going to quickly look over, and I can quickly see that t is actually 8, right? Because that's where the graph intersects the x-axis. And it only intersects the x-axis at 2 points. So 8, 0 has got to be my other answer. So therefore, when they're asking for the value of t, I know immediately that it's going to be 8. And so the answer is D for this question. Okay. And then finally, our last question here. What is the vertex of the quadratic f at x equals 3x squared plus 5x minus 8? And here they give you the quadratic in standard form. And this can be a little bit of work for you to complete the square and put it into vertex form to find the vertex. So if you wanted to speed things up a little bit, you could just directly put the full function into DESMOS, and then it'll spit out the graph for you so you can directly see where the vertex is. So again, you can click on the graph and then hover over the vertex point, and you can see the vertex right there. Okay, so that's a wrap on the second portion of this lesson, the characteristics of a function. I find that the SAT mostly asks questions like this about quadratic functions, and you can most easily apply DESMOS to quadratic function questions because the other ones may likely be easier to do in your head, but those 3 questions that we did were a pretty good overview. But of course, everything here is not a complete overview. College Board is always coming up with more questions, so it really is, at the end of the day, up to you guys to do as much practice as you can and practice those critical thinking skills so you can figure out any type of question that College Board tries to throw at you on the SAT, okay? So our next section is inequalities. Our first question, they give you 2 different inequalities, and they're saying a point with coordinates mn lies in the solution set of the system of inequalities above, graphed in the xy plane. What is the minimum possible value of n? Okay, so here, one thing that Desmos makes it really easy for you to do is you can just easily put in any inequality and it'll graph it out for you. So if you go down to this bottom left corner of the Desmos calculator, there's a button where it says show keypad, and it lets you input all these different inequality symbols. And this can be really helpful to you when you're faced with questions like this. So what I'm going to do is I'm going to plug each of those inequalities into Desmos. So starting with the first one, y is greater than or equal to minus 4x minus 3. And then the other one, y is greater or equal to 1/2 x plus 3. Whoa, I did not put that in right. Hold on a minute. There we go. Okay, so now we have 2 inequalities graphed, and you can see that there's some overlapping sections, and this is going to be our solution set. Okay, so the question is asking what is the minimum possible value of n? And remember, n is the y value of the points that lie in the solution set. Now, if I'm looking for the minimum possible value of n, I'm going to look at the lowest part of this solution set. And because both of these inequalities have an equal sign, I can actually just look at that intersecting point, because that intersecting point is counts as the solution set because it can fall into both inequalities, right? So if I click on this point over here and hover over it, I can quickly see that my minimum possible value of n is 2.33333 or 7/3. And to double check that I've got this correct, I can always go up this solution set area, and I can see that the y value just keeps rising above this point. So I know that I've got my minimum possible value. And plus you can see any point lower than this, there's no overlap between the inequalities. So that is the minimum possible value. Okay, moving on to the next question. They give you two inequalities again, and they're like, which point is a solution to the given system of inequalities in the xy plane? So for this type of question, again, I'm gonna graph the inequalities in DESMOS. I'm gonna go y less than or equal to x plus 7, and then y is greater than or equal to negative 2x minus 1. Okay, and now they're asking which point xy is a solution to the given system of inequalities. So again, I can see the solution set is right over here on the right where they overlap. And you can approach this question in a number of ways. You can either just look at it, look at the graph and look at the points and see and kind of like see which point is in the solution set area, or you can take advantage of DESMOS again and insert a point. So you're going to do bracket, and then you're just going to input the point as it is. Okay, and you can press label so you can see exactly where that point is with the coordinate, but it shows up as a point even without the label. So I'm just going to quickly put in all of my answer choices. 0, negative 14, 0, 14, 14, 0. And now I'm gonna just full screen so you guys can see a little bit better. But you can clearly see that I have 4 points here. Ooh. I have 4 points. I'm just gonna label so it's clearer for you guys. When you guys are doing these practice questions, it'll likely go much faster than when I'm just explaining these to you. So you might not even need to plug all of these in. But just for the purpose of explaining, I'm doing this, okay? So if you see all the points that I plugged in, you can quickly see that 14, 0 is the point that's in the solution set, right? Because it's in that overlapping region. So my answer is going to be D to correspond with the graphical representation. So that's how you answered that question with DESMOS. And then the last question is a little bit more tricky. It said you're buying apples and bananas, but you only have $15 and must buy at least 6 fruit. Apples cost $3 and bananas cost $1.50. And they're really nice. They give you both inequalities. They're not always like that. But they ask, what is the maximum number of bananas that you can buy? So here's the thing when you're entering these inequalities or any equation or anything into DESMOS. DESMOS only recognizes x and y. If you put in any other variable, it'll show up as a slider. And I can show you what that means. So when I'm putting in 3a plus 1.5b, it automatically pops up underneath telling me to add a slider because it doesn't recognize it as a variable like x and y to give you a function or an equation, okay? So remember to change your variables, but keep track of them in your head or write them down, okay? So for this this example, A is gonna turn into X. So X is gonna represent the apples. Y is gonna represent the bananas, okay? So I'm gonna put this in. x plus y. Okay, so now that I've put it in, we can see this chart. Oh, that's why it looked kind of weird. Not 33, 3. Okay. So again, you can see my solution set is where it's overlapping, and you can see it starts down here and it goes all and it overlaps all the way up. Okay. And for questions like these, it's really important to keep in mind what your variables mean. So again, x means apples. So on this x-axis, this is representing the number of apples you can buy under those conditions, under the conditions set out by the inequalities in the question, okay? And then the y-axis is going to represent the number of bananas you can buy under those specific requirements that they set out in the question. And those requirements are represented by this set of inequalities, okay? So what my overlapping area or my solution set means is it gives you all the different combinations of the numbers of apples and bananas you can buy while fulfilling those requirements. And what the question is asking is, what is the maximum number of bananas that you can buy under those requirements? That's kind of what's the word for it? It's like implied, okay? So I'm gonna look in my solution set and I'm gonna just give you guys an example. So for example, this coordinate 4, 2, that's in my solution set. So that means I can buy 4 apples and 2 bananas in under my specific set of circumstances. Now, if I am looking for the maximum number of bananas I can buy, I'm going to try and go as high as I can on this overlapping section, right? Because I want my y values to increase, because remember, y equals bananas, right? So I can go all the way up into my solution set until I hit 0 for my x values. And the reason for that is because once you go beyond that, you're going to start to be purchasing negative apples. And that doesn't make sense in the context of the of this question. So my maximum number of bananas I can buy is going to be 10, because that's the point when apples are 0 and I've completely maximized my money on buying bananas. And once again, I can't go beyond that. You might be like, well, that's actually not the greatest number of bananas you can buy, because look over here, I can be buying, hold on. Over here, I can be buying 11 and 12 and 13 bananas, but no, that can't work because your apple number is now negative. And that doesn't make sense in the question, in the context of the question, okay? So that's why our answer for this question is 10. 10 is the maximum number of bananas you can buy. Okay. So that is a wrap on the inequality section. Now we're going to move on to mean and median. So mean and median is actually pretty simple. If you ever get an SAT question asking for the mean of these data or the median of these data, what you can do is really simply just type in mean and then bracket and then fill in all your data and then close bracket. And then it'll shoot out the mean or median or whatever you need at the bottom, okay? So for this example question, it's asking for the mean. So I'm just going to input all my data. And then close bracket. And you can see it shoots it out at the bottom. It's 10. So therefore the answer is 10, okay? And it does the same thing with median. And it looks at the, if you look at the bottom, the answer is 7. So that's how you would approach these types of questions. Okay, now that was pretty simple. And we're going to move on to our last section. So our last section is circles. Now, for circle questions, it can be kind of tricky because DESMOS is only helpful in some situations, and in some situations it's not. So you have to be really discerning and careful to know which sections you should spend time on DESMOS for and which questions to not use DESMOS for, because with more math practice and when you're building up your skill set in math, you'll eventually find that using your brain and critical thinking skills is much better than plugging it into Desmos and fiddling around with the calculator, okay? So this is an example of a question that is helpful, or where Desmos is helpful for. So it gives you this circle equation, and it says the graph of the given equation is a circle in the xy plane. The point AB lies on the circle. Which of the following is a possible value for A? So what you're going to do is you're going to plug in this equation into Desmos. Okay, and now you can see in Desmos, there's this beautiful circle on the Cartesian plane, on the xy plane. And now they're asking for a point, which x value lies on the circle. That's basically what the question is asking. Now, you could go in and put every single x value into Desmos and then see which one lines up. But you can just look, if you click over here, you can check the minimum x value and then the maximum x value that the circle has basically in its range or domain. So if you look really closely, I can drag my little pointer all the way to one end of the circle, and it gives you the minimum value of the range of the circle. So it's -15. Because if you start to go down, it starts to go to -14. If you go up, it's -14. So -15 is the minimum. Now, if you go all the way to the other side, you get 7. 7 is my maximum value because if you go up or down, the x values just get smaller. So if my domain for my x values is -15 and 7, then by looking at these answer choices, I can see that only one of them fits, and that would be B, because only -14 is within the range of -15 and 7. So I just quickly choose B, and boom, the question is done. Okay? So that concludes my lesson review for how to use Desmos on the math section of the SAT. If you have any questions, you can always email me or leave a question in the comments and I'll get back to you. Hopefully you found this helpful, and thanks for watching.